This sample problem is about Newton's second law of motion with friction. An object of mass 3 kilograms is at rest on the surface of a plane inclined at an angle of 20 degrees with the horizontal. What is the coefficient of static friction between the object and the inclined plane? So this is our object right here. Its mass is 3 kilograms and it is at rest on the inclined plane. Now, when an object is on an inclined plane, so as we expand, our F net is equal to ma. Our F net would just be the forces along the axis of the object's motion. So in this case, once again, if we have an inclined plane, we're actually going to tilt our axis so that this is our x and this is our y axis. So in this case, we would be looking into the forces along the x-axis. So one of the forces would be the x component of the object's weight, which is headed in this, or which can be drawn like so, and it is directed down the inclined plane. And since the object is at rest, that means to say that there is a friction counteracting this x component of the weight, and it will be pointing in the opposite direction up the inclined plane. And this friction should be equal to the x component of the weight so that the object remains at rest. So our F net would then be Wx, and this Wx should be positive because if we have our Cartesian coordinate, this side here should be positive and the other side would be negative. This is positive y and this is negative y. Alright, so Wx points in the positive x-axis, so we will have positive Wx, and friction pointing in the opposite side of the direction of Wx, so it's going to be minus friction is equal to the mass of the object times the acceleration. Now, since the object is at rest, that means to say that the acceleration is equal to 0, so the object is not moving. So now we expand Wx. If an object is on an inclined plane, Wx is just equal to mg sine theta. On the other hand, friction is going to be mu s, since we're dealing with static friction, so it's going to be mu s times the normal force, and this is equal to 0. Mass times 0 would be equal to 0. Expanding this further, we will have the mass mg sine theta, which is our Wx, minus mu s, or the coefficient of static friction. Now, since the object is on an inclined plane, this normal force would just be equal to mg cosine theta. So if we draw that in our if we draw that in the figure, the normal force is actually this force right here. This is our Fn, and this is equal to the y component of the object's weight, Wy, and this Wy is equal to mg cosine theta. And since the normal force is equal to the weight, the y component of the object's weight, so therefore we could say that the normal force, Fn, is also equal to mg cosine theta, because once again, the normal force is just equal to the y component of the object's weight. And that is why we have here, as we expand the formula for static friction, we have mu s, and then the normal force now is mg cosine theta. And this is equal to 0. Now we substitute our values. We have the mass of the object is 3 kilograms multiplied by g, which is 9.8. Sine of the angle is 20 degrees, minus mu s is the coefficient of static friction. This is going to be our unknown. That's it. This is what we need to solve for. Multiplied by m, which is 3 times 9.8, cosine of the angle 20 degrees, and that is equal to 0. You put these values in your calculator with your mu s as your unknown, so you could substitute this with an x. Then mu s, or the coefficient of static friction, is equal to 0.36. This is the answer to the sample problem. So once again, if we are solving for problems related to the friction for objects on an inclined plane, we can have F net is equal to MA, and then the F net would just be equal to the x component of the object's weight, which is mg sine theta, minus friction, which points in the opposite direction, and that is equal to the coefficient of friction times the normal force. And for an object in an inclined plane, the normal force is equal to the y component of the object's weight, which is equal to mg cosine theta.